Am I audible? Hello everyone. Good evening to everyone. Hope everyone is doing very well, very fine, and everyone is doing very good preparation for NEET, right? So, chalo, let's just start our rapid revision session for this NEET 2025. And today we have come with the first session or first lecture with the chemistry, and the chapter is going to be structure of atom. Chalo. Before doing anything, let's just do something. What are the things that first of all you should know that what we are going to do in today's session? What are the expectations that you should have? The basic expectation that we should have is that here we are not going to have any derivation. So derivation will not be there, but of course we'll just try to complete all the different topics, important topics, and how to solve the question for those topics. Okay, so these are the things that we are going to do. And now what do you need for this session? Nothing, absolutely nothing other than one thing, that complete focus and of course a somewhat थोड़ी बात जान पहचान, a somewhat of knowledge of these things or whatever are the terms that we are going to use. These should be there, of course, because you are going for the NEET 2025. So I hope that you all would be aware about everything that we are going to study. So it is a revision session and we are going to complete it very fast, just in 1 hour. So of course we are going to be very much specific. So first topic that we are going to study about is discovery of fundamental particles. Now, discovery of fundamental particles, without any doubt, I hope you all know that what are the fundamental particles. Before that, a bit of background I would like to give you, that in atomic structure, we all know that we study about different models of structure of atom, right? The very first structure, or you can say the model, was given by John Dalton. I hope it was the first scientific model that was given. Now, what was in that model? The thing that he told, that atom is the smallest fundamental particle that is indivisible. So is it correct? No. Now we know that, of course not. Why? Because there are many different fundamental particles are there, so that is even smaller than atom. That is what we call it is subatomic particle. What are those subatomic particles that we generally deal with? Electron, proton, and neutron. So we are going to talk about the discovery of those electron, proton, and neutron. Now I would not going very much depth into it. Why so? Because it is no more given in the syllabus of NEET. You can just check it. It is there on the NTA syllabus. So, but still you should know that electron was discovered by cathode ray tube experiment. What that cathode ray experiment was there, I hope, and who did that? Of course, it was done by, the first thing that was done by Julius Plucker. Julius Plucker was the scientist who did this experiment and who found out that there is something that is, what to say, negatively charged thing is there, that is starting from cathode and going towards anode. Anode is the positive plate. If something is going toward positive plate, of course it should be negatively charged. So it was something about the cathode ray tube experiment. What is that cathode ray tube? Cathode ray tube is just, you can just imagine, I hope you have seen many different images of that there is a glass tube that is very less pressurized. You can say that almost 0.001 mmHg. So this much of small pressure and very high voltage. At such a high voltage and such a low pressure, the gases also start conducting the electricity. So these things that you should know. But once those gases start conducting the electricity, we see that there is something going towards the positive plate. So if something is going towards positive plate, means that is negatively charged. There are many things we studied, but the one very important thing that we saw, that on changing the gases inside that CRT, cathode ray tube, we found that E by M ratio, that is charge by mass ratio, was every time same. So whatever the particle or ray was there, whatever the ray or particle was there, it had E by M ratio same, irrespective of gas. Irrespective of gas we use. So what we can say, that this is fundamental. This is present in all the atoms that are present in the nature. Now next one we are going to talk about is proton. What is proton? I hope you all know about it. How do we show it? P positive we can show it. What is proton? I hope it is something that we did by the anode ray experiment. If it is cathode ray experiment, here it is anode ray experiment, or we can say canal rays experiment. Who did that? Of course Chadwick, but Goldstein. But the thing is, what he did in that experiment, he did the same thing, and almost same common things of results, so common type of results were found out. But the very important thing we found out, when we were changing the gases inside that, the E by M ratio was also changing. Why? Because this time it was not any of the fundamental particle that was coming from there, but it was the gases itself, the gases, or you can say ionic gaseous residue. So let's say if there is hydrogen, so hydrogen was going as H plus after removal of electron. If there was oxygen, it was converting into O plus by losing electron. O plus and H plus, both of them are different, but this electron is every time same. So if it is going towards anode, that is positive plate, while this was going towards cathode, that was negative plate. And because it was starting, or what they were expecting, that this was coming from anode, so that's why they called it anode rays. Okay, so chalo. So this was something, but what we found out, that E by M ratio different on using different gases. Now what about the neutron? I hope you all know that James Chadwick in 1932 found out this neutron. What was that neutron? Because what was happening when we were trying to find out the mass, every time we were having some gap between the mass, means it was not becoming like electron, proton, everything we have counted, but where is that some gap is there? That gap was something that was found to be neutron. Neutron is the, you can say, neutral particle. It has no charge. I hope you all know about it. And few things that you have to keep in mind is these properties of electron, proton, and neutron. Now everyone, you know that what is the symbol of electron? E or E minus, proton P or P positive, neutron N or N0. Now approximate relative masses. What is the relative mass? If it is proton has the mass, if let's say 1, the neutron is also considered to be 1. If someone asks you what is the mass in atomic mass unit, the hydrogen, you can say hydrogen atom or proton will have 1 AMU of mass. While if you talk about electron, so we should always know about it, that mass of electron equals to mass of proton by 1837 or 1836, better to remember. Why? Because 18 to the 36. I hope you understand it. Now, so it is the relative masses of proton and electron and neutron. Now approximate charges. You all know that if you talk about the electron has the charge -1, but if you talk about what is in coulomb, how much it counts, negative of 1.6 into 10 to the power minus 19 coulomb. The same charge is there in the proton also, but it is positive other than negative. On neutron there is no charge. I hope you all understand. Mass in mu and mass in kg. Very important, very important. The points that you have to keep in mind is this only, that what is the mass in kg? That is 9.1 into minus 31 kilograms. For proton it is 1.67 into 10 to the power minus 27. Similar for the neutron also. Neutron is a bit more, but you can see 1.67 into 10 to the power minus 27 kilograms. So these are the things that everyone we can keep in mind. Now alpha particles are represented by alpha particle. It is a very important thing that every time it will be coming. Why? Because later on we are going to study about alpha particle scattering experiment, many things. Alpha particle is nothing but, what is this? Is it lithium ion? No. Helium atom, helium nuclei. What is this? And many times students understand or remember just helium, and they just understand this helium atom. No, it is not helium atom, but it is helium nuclei. So if there is helium, and helium has how many of the electrons? 2 electrons. How many of the protons? 2 protons. Just understand it. So if you remove the electrons from it, and just you take the nucleus out of it, so that nucleus of where there is only proton and neutron is there, so that will be alpha particle. So basically it is bipositive, or you can say it has 2 positive charge, and it has the mass of 4 units, right? Just 2 proton and 2 neutrons are there, right? So what is there? Now the next question is the increasing order of the values of E by M ratio, that is charge by mass ratio. Very important type of question. Let me tell you, it is, just see that it is important type of question. E by M ratio. Always remember, you are not going to use the actual mass for finding out E by M. No, never. Just relative mass. Only relative mass. Chalo, tell me about the charge. For sure we know that for electron, it is what? Electron, proton, neutron, and alpha particle. It is alpha particle, right? Alpha particle. So for electron, what is the charge? I hope you all know that. What is the charge? 1. What is the mass? Mass of electron, I hope you all have seen that. It was mass of proton by 1836. That is what we can say, 1 by 1836. So what we can say, 1 by 1836. That is 1836. This value, E by M for electron. For proton, it is how much? The charge is how much? 1. What is the mass? Of course, it is 1. So 1 by 1, it is what? 1. What is the mass charge for neutron? It is 0. And what is the mass? 1. So therefore it is 0. But what about alpha particle? Alpha particle, the charge is how much? Of course, the +2. Helium nuclei has how much of charge? Because of the 2 protons, 2 divided by how much is the mass? There is 2 proton, 2 neutrons. So therefore, 2, 4. So therefore, it is how much? Half. So I hope you all can see that the biggest number is 1837. We want increasing order. So maximum should be electron. Okay. And minimum should be neutron. So neutron and then alpha particle, then proton. Neutron has how much? 0. Alpha has how much? Half. Proton has 1, while it is 1836. Very easy. So never ever use the actual masses. Use just the relative mass and relative charge. Please. Thomson atomic model. But once we found out all those electrons and protons, so different scientists started thinking of, yeah, how to make a structure or model of structure of atom where we can accommodate all these electrons and protons. Chalo. So for that, the first theory, or you can say after that, the very first model of the atom came by Thomson's, the named Thomson's atomic model. Why? Because Thomson gave that. So now what was the main thing? The main thing that it told, okay, because we all know that electron, basically by the cathode ray tube experiment, the charge and E by M ratio was found by J.J. Thomson only. So because J.J. Thomson found out, he was very much curious and he was thinking, oh yeah, let's give some atomic model. And in that model, what he did, he just thought, or he just imagined atom as the sphere, that is positively charged sphere, where there are many of the electrons are ingrained inside it. Just like, you know, watermelon. Like watermelon, all the red part is the positively charged, and while all the seeds are negatively charged electrons. So just he imagined it like that. I hope everyone you know that. Now, according to this model, total positive charge in the atom is equal to total negative charge in the atom. So therefore, it talks about the neutrality of the atom. So it could explain that. Which of the following properties of the atom could be explained correctly by Thomson's model atom? I hope you all have studied about it. That overall neutrality of the atom. For sure, it's correct. Next, Rutherford's atomic model. The next one came in this. What was that? But was it correct or not? No, of course, Thomson's model was very wrong. So therefore, to explain something more, there came Rutherford's atomic model. But how did it come? Basically, he did the gold, everyone you know that, alpha particle scattering experiment. He just put a gold foil, that was very thin gold foil, and he just bombarded it with the very highly energetic alpha particles. These alpha particles, what he was expecting, because according to the Thomson's model, so atoms are what? They are like sphere, that is positively charged sphere, and you all know that alpha particle is also positively charged, so positive will be repelling. So what he was expecting, when I will bombard the alpha particle, it will come back just like a rebound, but it didn't happen. What happened? Most of the alpha particles just gone through it. Arey, how did this happen? Why did this happen? Means, of course, we can say that there is a lot of space, there is a lot of vacant space inside the atom, for sure. And so it was most of them, but what happened about others? Of course, few of them got deflected and very few got just back. You can say just like something had collided and it just came back. So what we can say? So there is a very small but very dense and very heavy region inside the atom that is positively charged. That's why that alpha particle went and came back directly. So of course, what we can say? We will have to give some name to that very small region that is positively charged and that is also very heavy. That is called nucleus. So basically with the Rutherford's model, what we found out? We found out nucleus. And then there he explained the proton is inside the nucleus. So proton, the name first time was taken by this Rutherford's atomic model. That's why we call that proton was discovered by Rutherford. Okay. Now this model is based on the alpha particle scattering experiment. I hope you all have already seen these things many times. I will not waste any time. Conclusions, very important. Always just remember these things. In an atom, all the positive charge of the particle, proton, is concentrated at the center of atom called nucleus, and electrons is revolving around the nucleus. Very nice. Next, size of the nucleus is in the range of femtometer. That is how much? 10 to the power minus 15, 10 to the power minus 15 meter. And the size of atom is in the range of angstrom. That is how much? 10 to the power minus 10. So always remember, radius of nucleus by radius of atom, it will be how much? It is 10 to the power minus 5, 15 divided by 10 to the power minus 10. It will be 10 to the power minus 5. Or you can say radius of atom is 10 to the power 5 times of radius of nucleus. You have to keep in mind. Next, drawbacks. This model does not able to explain the arrangement of the electron inside an atom. But of course, he had to say na, of course electron is already discovered. So electron ko bhi to koi jagah do na bhai. Some there should be some place inside the atom. So what he thought, as a, of course, proton is positively charged, electron is negatively charged, so they will be electrostatically attracting each other. So what he thought, okay, so means this there will be nucleus, and around it electrons will be revolving just like this, and there will be electrons, and in any orbit. He just told like, okay, electrons will be revolving around it. But was it correct? No, for sure. The Maxwell's electrodynamic theory now comes to the picture, and it was already given. So what was that? It tells that if there is any charged, let's say there is any charged particle is there, and if that is inside some external magnetic field, so it will keep on losing its energy by radiating electromagnetic waves. So electron is also charged, and of course it is under the magnetic and electrical field of the nucleus. Proton for sure. So therefore it should always keep on radiating the energy, and after radiating, electron choti is done, it's a small entity. What will happen? It will keep on removing its energy or losing its energy. Ultimately it will fall inside the nucleus. If it falls inside the nucleus, means the whole existence of the atom will be vanished. But it does not happen. So for sure there is some problem is there inside this, some fundamental weakness is there in this model. So now that model, the next model that is going to be there, I hope you all know that. What is that? Yes, Bohr's atomic model. So this model does not able to explain the arrangement of the electron inside an atom, and this model does not able to explain the stability of atom. Basically it is not does, is. Okay, next, Rutherford's experiment on scattering alpha particles showed for the first time that atom has, I hope you all know that, nucleus. Next, which of the following conclusion could not be derived from the Rutherford's alpha particle scattering experiment? Bataiye bhai. Chaliye. Most of the space in the atom is empty. Yes. The radius of the, so basically it is what? True. The radius of the atom is about 10 to the power minus 10 meter, while that of nucleus is perfect. It's also true. Electron move in circular path of fixed energy called orbits. No, I hope you all know that this is something, this was told by, yes, Bohr's model. Now, electrons and the nucleus are held together by electrostatic forces of attraction. For sure it was told, right? Next, Planck's quantum theory. Why am I going to Planck's quantum theory? There is a reason. Because there was parallelly one more. I'm directly cutting to it. Of course, I cannot explain many things, why these things were parallel, why atomic model, and parallelly I'm going to talk about light. Why? There is a reason. But leave it. Right now, just study it. Why? See, Planck's quantum theory. What is that, and how did this come? Parallelly, there was one, one kind of debate was going on. That light is a particle or it was a wave, and because it has a lot of things to do with the atom, right, or structure of atom. That's why we had to study about, okay, what is this light and what is the nature of the light. So 19th century was the time when light was completely considered to be that it is a wave. Okay, wave. Why? Because light showed few kind of properties. What were those properties? Like, I hope you all know that: reflection, refraction, then diffraction and interference, polarization. So these things were the effects due to which it was considered, okay, light is only wave, only it's just like wave. Okay, but there was a catch. What was the catch? Now see, Planck's quantum theory. Now how did he explain light? He considered that light is nothing but this is made up of small packets of energy, and those small packets of energy is nothing but quanta. But if it is of light, it will be called photon. Okay, just consider it that light is nothing but it's a kind of wave of water, and inside that wave of water there are mugs, or you can say jugs of water, right? In every jug there is some amount of water is there. Now we all know that. Pata to hai na? Let's say that there are two different electromagnetic waves is there. One is of higher energy, one is of lower energy. Okay? So if something is of higher energy, so you can consider that it has bigger mugs. So bigger mugs holds bigger amount of water. Bigger amounts of water means bigger amount of energy, right? But if there is, let's say, smaller energy electromagnetic radiation is there, so it will have smaller mugs. So if small mug is there, small amount of water will be means there will be small amount of energy. So what we can say, that every photon or every quanta has some energy that depends on something, and that is nothing but, basically, I hope you all know that the energy of photon, or I'm talking about one photon, equals to is basically n h nu, basically h nu, or h times of nu. Nu is what? Frequency of the light, h times of nu. Now, if there are n different, if n photons are there, so it will be n h nu, and nu is equals to c over lambda. I hope you all know that c is speed of light, while lambda is the wavelength, right? So nu equals to c over lambda. What we can say? So from here, the energy can be told as hc over lambda. So these things, I hope you all know that. What is this h? H is nothing but it is Planck's constant. What is the value? 6.626 into 10 to the power minus 34 joules second. So these are the things that you have to keep in mind always. Next, in case of light, this quantum is called, I hope you all understand it, photon. The energy of each quantum is directly proportional to the frequency of the radiation. I hope you all can see that. We have already studied about it. Now, one more thing from here, I will say, you should know that 1 by lambda equals to nu bar. It is nothing but wave number. So it is what? E equals to hc nu bar. One more relation, just to keep in mind, right? So these things, now E equals to 12,400 by lambda in electron volts. If the energy is given in electron volt, please keep in mind, very, very, very important. When lambda is in angstrom, it is very much important. Lambda को meter में भी दिया है, तो keep convert into angstrom, picometer to angstrom. Okay, then only use it. Next, the total amount of energy emitted or absorbed by a body is whole number multiple of quantum frequency of radiation. For sure, you just understand it. If that wave is there, inside wave there are mugs. So if it has to give the energy, it cannot give half of the mug. It will give only complete full mug, right? So it will give either 1 mug, 2 mug, 3 mug, 4 mug. So it can never give 1.5, 1.25. No, it cannot happen. So always remember that energy is always quantized. Now, the number of photons of light with a wavelength of 600 picometer, that provides this much of joules of energy. So I hope you know that. What is the formula? E equals to n hc over lambda. Lambda is given, okay. Energy is given. What is given? Sorry, number of photons of light. Lambda is given. How much it is? 600 picometer. 600 picometer means how much of meter? 600 into 10 to the power minus 12 meter. That is 6 into 10 to the power minus 10 meters. Keep in h value, you know, c value, you know how much it is. 3 into 10 to the power 8 meter per second. Why we are keeping everything in SI unit? The reason being that energy is here given in joules. Keep in mind, put these values and you will get the correct answer, that is 200. Electromagnetic spectrum. What is electromagnetic spectrum? Always remember, if these electromagnetic radiations are there, if you just if you just put them in increasing or decreasing order of their frequency or wavelength, whatever you get, that order or that series is called as the electromagnetic spectrum. Now, in that electromagnetic spectrum, you should always keep in mind, if you go by increasing order of frequency or decreasing order of wavelength, the first one will come as radio waves. Then, yes, of course, where you eat, where you cook those foods, of course, what do you say? Sorry. So, what do you call it? So here we go, radio waves, and then we will come to the microwave, and then once we go with the microwaves, the next one will be infrared, before red. So red color se pehle jiski kam frequency hoti, what is that? Infrared. And then comes the visible light. Visible light mein all the colors are there, from violet to red, Vibgyor, yes. And then after that violet, more than violet, whatever is the frequency, that will be called ultraviolet. And after that there comes X-ray, then gamma, and then there comes cosmic rays. So always keep in mind, but we are going to study only right now about this, you know, this what to say, visible. In the visible light, we know that Vibgyor, VIBGYOR. From here to here, what is happening? From here to here, the frequency is going to be reduced, while wavelength is going to be increased. The reason is frequency is inversely proportional to lambda, that is wavelength. Actually, next one, spectrum. We all know that there are two types of spectrum. One is emission spectrum, one is absorption spectrum. What is emission spectrum? Just think about it. If let's say that there is some gas is there inside a chamber, And if you just excite this, excite it by anyhow, either by giving heat or by electric spark, so what will happen? These electrons will go to a higher energy state, but they will not always remain there. They will come to the lower energy state, of course. So once they go from high to and then they come to low, so there will be some amount of energy difference. That amount of energy difference, whatever is there, the same amount of energy will be released. Whatever is the amount of energy is released, that will be emission, right? That's why the whatever the spectra we get, that is emission spectra. How does this emission spectra looks like? You can see that this will be looking something like, there will be few lines will be there, whatever the, let's say wavelengths it is emitting, only these wavelengths you will see on the screen. So these are called emission spectra. Are they continuous or discontinuous? They are discontinuous. Are they line or broad? Of course they are line kind of, so they are discontinuous line spectra. While what about the absorption spectra? Absorption spectra is due to the absorption of the light. Let's say there is a white light and we are passing it through a gas. For gas may it has different energy levels according to Bohr's model. Now whatever is the energy level difference is there, it will absorb that energy. Once that energy is absorbed, it will go to a higher energy level. Yes. So whatever is the amount of energy or whichever is the wavelength that it has eaten, it will not show up in the on the screen. So here on the screen or film, it will not be seen. So there will be few different lines will be missing out of it. Why? Because those lines are already absorbed by the gas, right? So this will be a broad spectrum kind, but the thing is that this will be continuous. It is not a discontinuous thing. And when you add both of them, emission and absorption spectra, you get the whole, you can say white light or you can say original light, right? Chaliye. Next, we are going to talk about the Bohr's atomic model. Now, on the basis of, there is something that is hydrogen spectra that we are going to study just after that. That's kind of emission, emission spectra. There came Bohr's atomic model. What is the Bohr's atomic model? The few postulates you already know about it, and you should know about it. The electrons in the hydrogen atom can move around the nucleus in a circular path in a fixed radius and energy called orbits. That is energy, that is stationary state or allowed energy states. The energy of the electrons in the orbit does not change with the time. So if there is any electron that is just revolving in any one orbit, it is not going to either emit any energy or neither it is going to absorb any energy. So this solved a problem. What was the problem? The problem that was raised or the question that was raised with the Rutherford's model, right? Why would electrons would lose the energy? But here what he explained, no, it is not going to lose if it is going to be in one stationary orbit. Next, the electron can move from lower orbit to higher orbit or vice versa, or it can go from higher to lower also. If lower to higher means it is absorbing the energy. If lower to higher or higher to lower means it is emitting the energy, right? Next, the frequency of the radiation. One more thing that you have to always keep in mind that about the Bohr's model, here it talks about it only deals with or only deals with one electron system. What is one electron system? I hope you understand. Hydrogen, He plus, Li plus 2, Fe plus 25, whatever it is. Wait, you understand it, right? Now, only deals with the one electron system. And next thing is, it is, now here, we are going to talk about the angular momentum quantization or quantization of angular momentum. What is that? At the formula MVR, that is angular momentum, equals to NH by 2 pi. And this formula is going to be very much used in the solving many of the different formulae. So please keep in mind here, the frequency of the radiation absorbed or emitted when transition occurs between the two orbits differ in the energy by delta E. So delta E, nu is equals to E by, because everyone you know that delta E equals to H nu. So nu will be delta E by H. What is that? Delta E, E2 minus E1. So that is something I hope you can do. The angular momentum of an electron in a given stationary state can be expressed as an equation, that is this. I hope you all understand it. So what is this N? N is here, it is the orbit number. What is that? Orbit number. Orbit number 1 is also known as K, 2 is L, 3 is M. I hope you understand. 4 is N. Okay? चलिए आगे बढ़ेंगे. Application of the Bohr's model. With the help of electrostatics and the help of centripetal forces, by applying that law of quantization of angular momentum, we get few very important results. That is what? चलिए आइए देखते हैं. Radius of orbit, that is Rn, in the nth orbit of of nth orbit or nth stationary orbit Rn equals to 0.529 into n square by z angstrom. Next, velocity will be how much? 2.18 into 10 to the power 6 into z by n. But what? Meter per second or centimeter per second? Please keep in mind meter per second. Next, the total energy of electron in Bohr's orbit. What is that? En equals to minus 13.6 into z square by n square. But it is going to be EV, that is electron volt per atom. If you convert into joules, how much it comes? It comes out to be 2.18 into 10 to the power minus 8 joule per atom. See, this is not a very tough thing to remember because 2.18 is being here also and here also. So you can remember it very easily, right? But if it is joule per atom, if it is kilojoule per mole, it will be minus of 1312 into z square by n square kilojoule per mole. Or if it is in kilocalorie per mole, minus of 313.6 into z square by n square kilocalorie per mole. What are the most important ones? This one and this one. Very, very, very important to keep in mind. Next. If an electron shows transition from N2 to N1, the energy level, then the energy change delta E will be E N2 minus E N1. That is how much? Minus 13 into 1 by N2 square minus 1 by N1 square into Z square. That is nu bar equals to RH. What is this? It is nothing but it is Rydberg's constant. Where we are going to study about it? We are going to study about it in hydrogen emission spectra. This formula I hope you all understand. Nu bar is the wave number of the line in hydrogen emission spectra, right? And RH was Rydberg's constant. How much is the value of this? 10, 9, 6, 7, 8. 10, 9, so just think about it. 10, then 9. And then, first of all, opposite, 10 to 9. And then come to 6, 7, 8. Or 6, 7, 7. The real value is 6, 7, 7. But for remembering, I just said 6, 7, 8. So 10, 9, 6, 7, 8. But it is what? In centimeter inverse. It is very much important to remember this unit. Without unit, you may just be wrong. Now, here relation between total energy, potential energy, and kinetic energy of the electron in nth orbit or nth energy state. How much it is? Always remember that total energy is equal to kinetic energy plus potential energy, and potential energy equals to 2 times of total energy. Just keep in mind, because total energy, this formula is there that we have studied. It was for total energy. If you find out total energy, you can find out potential energy by multiplying with 2, while kinetic energy equals to negative of total energy. And if there is potential energy and kinetic energy, what is the relationship? So potential energy of minus of 2 times of kinetic energy. So these things you have to keep in mind. Next one, the velocity of an electron in the third orbit of hydrogen. So everyone, we know that. What is the formula? It is asking for centimeter per second. Just keep in mind. So what is the formula that we know? We know that Vn equals to 2.18 into 10 to the power 6. But it is in meter. If it is centimeter, then we make it 10 to the power 8 into Z by N. What is the Z? The hydrogen has Z value. That is atomic number. It is how much? 1. And what is the N? N value is 3. So 1 by 3. You can just do the formula, you will put the formula and get the answer, right? Next, according to the Bohr's theory, the angular momentum of an electron in fifth orbit will be how much it is? I hope you all know that angular momentum equals to nh by 2 pi or n times of h by 2 pi. What is the n value here? The fifth orbit. So n value is how much? 5 into h by 2 pi. How much it is? 2.5 into h by pi is the answer. The radius of the Bohr's first orbit in hydrogen atom is this much, but it is not given in angstrom. Keep in mind, it is in nanometer. That's why it is 0.053. Otherwise, you will say that how much it was? 0.529 angstrom. So in nanometer, it will be 0.0529 nanometer, right? The radius of the second orbit of helium ion will be, right? So the same thing is here also. So what we can say? For radius of helium plus that too of the second, how much it is? 0.053 into n square by z. What is the n key value? N key value is 2. So 2 square by z. What is the z key value for helium? It is 2. So cancel it, and this much of, but this much will be nanometer. Just solve this, and 0.0, that is 0.106. So C will be the correct answer. Next one, what is the potential energy of an electron present in n shell? N shell means KLMN, remember? So what is that? K is first orbit, L is second orbit, M is third orbit, N is fourth orbit. So N value is equals to 4 of beryllium plus 3. So what is the value of Z? Z for beryllium is 4. So what is asking for? Potential energies. First of all, find out E total. It is how much? Minus of 13.6 into Z square by N square. What is the Z square? 4 square. What is N square? That is also 4 square. Cancel this much of electron volt. But it is E total. But we know that E potential is 2 times of E total. That is 2 into minus of 13.6. That is minus of 27.2. So option D is the correct option. Next one, the kinetic and potential energy of electron present in the third Bose orbit of hydrogen atom are. Homework for you. I hope you all can do it. What is the formula that you are going to use it? First of all, you find out ET by minus of 13.6 into Z square by N square electron volt. So what we can do? Once we got ET, so EP will be 2 times of ET, while EK will be negative of E total. Please do it and get the answer. Next, hydrogen line spectrum. I told you something, that the Bose orbit, that Bose theory came just because of hydrogen line spectrum only. But I am teaching you here. The reason is because it has better to explain, just for the explanation purpose. Now, hydrogen spectrum, it is nothing but it is emission spectrum. I'll not go completely inside the explanation. I'll just tell you the things. Those are important for you. Hydrogen line spectrum, it is nothing but it is a kind of emission spectra. Now, what is this emission spectra over there, and what was things that we observed into it? See, when there was some light was passed through the hydrogen atom. Let's say hydrogen is there in a chamber, and some light is just passed through it. What will happen? This will absorb that light. Once that absorbs the light, what will happen? The electrons from lower energy level to go to the higher energy level, but they will not always remain there. They will also come down. Once they come down, some of the energy will be emitted. Whatever the energy is emitted there, this will be observed and taken on the film, and whatever the things are there, that is called spectroscopic studies. Now, something very important, and you can say very interesting thing is there, that why it is so important. The point is that every different element has some characteristic, this emission spectra. So if there is of hydrogen, so it is every time from wherever you take the hydrogen, every time the same spectra will be there. Helium, then every time it will be same spectra. So for every different atom, it was giving a characteristic same kind of spectra. So it was a very great thing to find out, okay, if there is a very distant sun or star is there, so what are the elements inside that sun with the light that is coming there? If we do the spectroscopic study of that light, we'll see that okay, these spectroscopic studies are there, and these are the data that we are coming. So means, okay, these are the elements that is present in that sun or in that star or in that planet, whatever it is, right? These things you have to understand. Now, what is that? This hydrogen emission spectra. We got many of the different series on basis of what? If let's say that if electron is jumping from very high energy level to first energy level. So first energy level means ground state. If it is coming to ground state, so all these, let's say it is coming from 7 to 1, 3 to 1, 2 to 1, from anywhere to 1, it will be called Lyman series. And if it is coming from any higher energy state to second energy state, that will be called, it is called Lyman series, while it will be called Balmer series if it is coming to second one. You can see it is in infrared region. Just a minute, where it is? Okay, first one, and it will be in second one. So of course it will be called Balmer. It is what? All these are Lyman series. These are Balmer series because they are coming to the second one, and if they are coming to third one, they are called Paschen series. And if it is coming to fourth from higher, it will be called Brackett. If it is coming from higher to fifth, Pund. If it is coming from higher to sixth, it is Humphrey. I hope you understand it. So there is one thing that is every time constant. It was lower energy level, from where higher energy lower to lower energy level that electron is coming, right? Now, for this, the very first thing, or the very first scientist who studied about this, he was Balmer. Why Balmer studied it first? The reason is that Balmer, whatever the series that Balmer found out, it was in the visible light. That's why it was very easy to be identified. That's why this Balmer was the first person to study that. But later on, Lyman and many different person and scientists studied it. So later on, this Rydberg gave one formula. I hope you all know that. It was given for the wave number of the emission spectra, or you can say line of emission spectra of hydrogen. And what was that? It was equals to RH into Z square 1 by N1 square minus 1 by. I hope you all remember this. Now, Lyman made discovered by Lyman. All these names are given on the basis of scientists only. Regions are ultraviolet for Lyman, visible for Balmer, infrared for Bastian. All of them are for infrared only. So only you have to remember that ultraviolet is for Lyman and Balmer is for visible. All others are, you all can see that. What are these N2 value? N2 can be anything, but N1 value is always fixed. That is what? 1, 2, 3, 4. And one more thing that I would like to tell you, that if it is coming, let's say from 2 to 1, so it will be called alpha. If 3 to 1, difference is how much? 2. It will be called beta. 4 to 1, how much is difference? 3. It will be called gamma. Gamma of Lyman, beta of Lyman, alpha of Lyman. What about this? If it is about, let's say it is Balmer. So if it is coming from 3 to 2, so coming to 2, Balmer. But which from 3 to 1? It is alpha. 4 to 2, how much is the difference? 2. So it is beta. 5 to 2, how much is the difference? 3. So it will be called gamma line. I hope you understand it, right? And if it is coming from infinity, think about it. If it is coming from infinity to 1, it will be called limiting line of the Lyman series. If it is coming from infinity to 2, it will be called limiting line of the Balmer series. If it is coming from infinite to 3, it will be called limiting line of the Bastian series. I hope you understand it. So on. Next, let's go to the next one. These are the formulae. I hope you all are very well aware about it. We have studied about it right now only. So 1 by lambda equals to nu bar equals to wavelength, that is RZ, wave number, that is RZ square into 1 by N1 square minus 1 by N2 square. Nothing, not a big deal, right? You all can remember it, and you have already studied about it. It is meter square, that's why it is 10 to the power 7. If it was centimeter inverse, it will 10 to the power 5. Please keep in mind. Next, hydrogen line spectrum. Hydrogen line spectrum में the first line or starting line, initial line, that is lambda max. सोचो, if it is coming from 2 to 1, so energy difference is very less. If energy difference varies, lambda will be high, while the frequency will be less, because energy is directly proportional to frequency, but inversely proportional to wavelength, right? So this is something that is first line, that is also called alpha line. उसके लिए for alpha line, lambda is max, while frequency nu is minimum. While last line, that is also limiting line or series limit, that is here the energy will be maximum, so nu will be, frequency will be maximum, but lambda will be minimum, and it will be also called limiting line. Limiting line. So first line of any series is alpha line, second is beta. I hope you have already studied about total number of emission lines between N2 and N1. If they ask you that it is the highest, that is N2, and N1 is the minimum or is the lowest, from there to where to here coming. So number of spectral lines will be how much? N2 minus N1 plus 1 into N2 minus N1 divided by 2. But what if they are asking that if it is coming to ground state? So for ground state, N1 will be equal to 1. Yes or no? For ground state, if N1 equals to 1, that is ground state. So in such case, the formula becomes N into N minus 1 divided by 2. Please keep in mind. One more type of formula, please. Yes, it is also very important. Yaar, batana hi padta hai. If let's say there is Lyman, and if let's say there is any some kind of, let's say 8 to 1. This is the you can say many different types of lines we are observing. Now it will be asking how many number of lines observed in Lyman. It will be whatever is N2, better than keeping it 8, consider it as N. N2 somewhere it is coming. So how many of the Lyman series we will be getting? How many lines in the Lyman series we will get? N2 minus, or you can say N minus 1. Number of lines in Balmer will be equal to N minus 2. So basically it is what? It is the N1 value, and it is what? Final, that is N2 value. So number of lines in Bastian series will be N minus 3. In the bracket it will be N minus 4. Kund N minus 5. I hope you understand it. So if they ask you particularly about this, only this series, how many of the lines will be there? So you can find out with this formula. Next, Balmer series of hydrogen spectrum comes in range. Which range? I hope you all know that it is visible range. Next, if the shortest wavelength of hydrogen atom, shortest wavelength means highest energy, highest frequency is for the limiting line, means N2 will be equal to what? Shortest wavelength means N2 tends to infinite, and it is of Lyman, so means N1 equals to 1 is X. Then longest wavelength for the Balmer series, means longest wavelength means you can see that Balmer means N1 equals to 2, and for longest wavelength energy should be minimum. For energy to be minimum, the difference between the energy should be minimum, means N2 should be 3. So means it is going from 3 to 2, right? So just see that. So here, what is that? We know that if the shortest wavelength of H, that is 1 by X, that is nu bar. I hope you all know that. It is equals to RH into Z square, leave it for hydrogen only, into 1 by N1 square. N1 square is how much for Lyman? 1. 1 by infinite is how much? 0. So it is how much? X will be 1 by RH. Now just use it here only, but we know we want what? We want the new wavelength. Now what is that longest wavelength? Just think about it. 1 by lambda will be equals to RH into Z square, leave it, 1 by N1. What is the N1 value here? 2. 1 by 4 minus how much is that? 1 by 9, because we are talking about the N2 equals to 3. So 3 square is how much? 9. How much it is? 9 minus, it is 5 by 36. 5 by 36 RH. It is how much? 36. So therefore what we can say? Lambda equals to 36 by 5 RH. 1 by RH is X. So it will be 36 by 5. 1 by RH is how much? X. 35 by 36 by 5X. I hope you all can see that. Easy hai bhai. Bahut easy hai. Next. Limitations of Bohr's model. What were the limitations of Bohr model? Please. Bohr's theory does not explain the spectrum of the multi-electronic atom. Of course, we have studied about it, that it only deals with the single electron. Bohr's interrelated quantum theory of radiation and classical laws of physics without any theoretical explanation. This was the biggest drawback of this model, right? And it could also not explain the Zeeman and Stark effect, because not only those solid lines were being seen, but also on magnifying it, we saw that many of the fine lines were also there. So what is that fine lines signifying? He could not explain it, right? So this was something that is Zeeman and Stark effect. Bohr's theory does not explain the fine structure of the spectral line, that is only. And under the magnetic field, when these lines were splitting, it is called Zeeman, while under the electrical field, when it was splitting, it is called Stark effect. That it could not explain. Next, photoelectric effect, very important. What is the photoelectric effect? With the help of Planck's quantization or quantum theory, Einstein explained very beautifully one very important concept, that is photoelectric effect. What is photoelectric effect? When the light strikes any of the metal surface, some of the electron gets knocked down or they get uprooted. Why do they get uprooted? Because every light has the energy or photon. One photon will interact with one electron. If that photon has sufficient energy, it will uproot the electron. Let's say any electron needs 100 unit of energy. I'm not talking about how much, what is that unit? No, 100 unit of energy. If a photon is giving it, let's say 90 unit of energy, how much ever number of photon you give, it will not take it, because every electron is going to deal with only one photon. It is not going to absorb two photons. So what we can say, it needs any one photon, but more than what it needs minimum energy. Minimum energy needs 100 to get uprooted. So if you give 100, so electron will take that but come out of atom, but it will not have any extra energy to go. So means it will have zero kinetic energy. So how much is this energy that it is taking just to come out? It is called threshold energy, and the frequency with respect to that threshold energy is threshold frequency. Next, if you give, let's say 120 unit of energy, so 100 unit will be needed for just uprooting the electron. Let's say electron comes out of it, but extra 20 will be there with this for the kinetic energy. So this extra energy is nothing but it's the kinetic, or you can say maximum kinetic energy of that electron, right? EK max. So how the whole formula or how the whole things goes like, the photoelectric effect is a phenomenon in which electrons are ejected from the surface of a metal when the light is incident in it. These ejected electrons are called photoelectrons, because of course they are coming due to photo. There is a minimum frequency called threshold frequency, which can just cause the ejection. These frequency varies with the nature of the metal. Of course, if the metal is very easily giving the electron, of course it can change, right? The higher the frequency of the light will be, the more the energy of the photoelectrons will have. Of course, if you give higher energy, let's say 180 unit of energy, so 100 just to uproot extra will be 80. The more the kinetic energy will be there. So what is that? This is the This is the energy of incident light. What is that? It is the threshold energy. Threshold energy is also known as work function. Work function, that is also known as phi, and why the rest of the energy is nothing but Ek max. H nu equals to H nu naught plus half of mu square. From here, half of mu square equals to H nu minus H nu naught. I hope you all can see that, and very easy to understand it, right? The kinetic energy of an electron accelerated from the rest through a potential energy of 5 volt will be, okay, so you should know that kinetic energy equals to charge into potential. Charge into potential. What is the charge? Charge is 1 electron is there. So how much is the charge on that? 1e into, or you can say 1e, and potential is how much? 5 volt. So what we can say? 1 into 5 is how much? 5 electron volt. How much is the total energy? 5 electron volt. That is how it is coming, right? The electrons are emitted from zero velocity from the surface of a metal when it exposed to radiation of wavelength this much. The threshold frequency. Are very easy, right? So it is telling that electrons are emitted with zero velocity, means it just came out of the metal. It is not having extra energy. Means jo bhi energy thi, that is nothing but it is the threshold energy, or you can say work function, right? So this wavelength will be corresponding to this frequency. So nu will be equals to C over lambda. Use the formula. Lambda is already given how much? 6800 angstrom. Convert into meter. That is 68 into 10 to the power minus 8 meter. C, I hope you all know that 3 into 10 to the power 8 meter per second. चलिए भाई आगे बढ़ेंगे. Next, 12 joule of energy is required as a work function of a metal. Means remember what is that? Phi equals to 12. Photoelectric effect. 100 packets of energy, each having 10 joule, is falling in. Is it sufficient for ejection of electron? I told you, if you give 99 or 90 also, if it needs 100, if you give infinite photons, doesn't matter, it is not going to be ejected because it needs that minimum energy. That is how much? Either that work function or more than that. But this is how much? 12 joule. But how much is each having? All these photons are having only 10 joules. So phi equals 10, while the energy of the incident light is how much? 10 joule. It is not sufficient. No, not sufficient. Next, quantum mechanical model of it. Very, very, very important. There are a few theories that we have to keep in mind and we should deal with. What is de Broglie hypothesis? De Broglie talks about the dual nature of light. Dual nature of light. Dual nature of light. What it says? It says that E equals to mc square and E equals to h nu. So it E equals to mc square and converted into h nu. The final formula that we get from here, that lambda equals to h by m into v, or h by p. So lambda equals to h by p. This is the formula that comes from the de Broglie hypothesis. But p can also be written as h by root of 2m ek. Ek is nothing but kinetic energy. Let's say that this kinetic energy is coming due to some external electric field in a, and that too for any charged particle. It will be h by root of 2m q v. So these things I hope you can understand. So these are the formulae you have to keep in mind. This is only for the charged particle, only for charged particle, not for any uncharged particle. Please keep in mind Heisenberg's uncertainty principle. What Heisenberg's uncertainty principle tells? It tells that if there is a very, very small or even subatomic particles are there, so at that part any particle also have the wave nature. So they will have, so they can never be exactly told what is the position or what is the momentum. So you can exactly never say what is the position and momentum of that electron. And it is Heisenberg's uncertainty principle. What is the postulate? What is the formula of it? Please remember that delta x, that is, I hope you understand, uncertainty in position, into delta p. Delta p is what? Uncertainty in momentum is more than or equal to h by 4 pi. But for question solving, do not use inequality, just use equality, please. Now it can also be written as delta x into delta v. Delta v is what? Of course, uncertainty in velocity is greater than or equal to h by 4 by m. It can also be written as one more form, delta E, that is change in energy, or into delta t, that is change in time, is greater than or equal to h by 4 pi. all these formulae are for the Heisenberg's uncertainty principle. Then we are going to talk about Schrodinger's wave equation. Schrodinger's wave equation के जितने भी E psi equals to H psi. It is not of any use for you. Psi is what? Wave function. Nothing of any use right now for you. Directly we are going to talk about what it deals with. It deals with the orbitals. What is orbitals? Orbitals inside any atom is that region where there is maximum chance, or you can say maximum probability of finding an electron is there. So that is what Schrodinger, that is what it is given by Schrodinger's wave equation. Now, what does that Schrodinger's equation gives the best thing, or you can say the most important thing? It is what? Quantum number, right? Quantum numbers. What are the quantum numbers? I hope you all know that N, L, M and S. But S is given by Pauli's exclusion principle, and these are given by Schrodinger's wave equation. So quantum numbers, I hope you all know that. What is this? Principal quantum number, azimuthal quantum number and magnetic quantum number. It is what? Spin quantum number. Shape of orbital. Next thing that we are going to study about is shape of orbitals. I hope you know that. S has the spherical, P has the dumbbell, D has the double dumbbell, F has the quadruple dumbbell, of course very complex, not to think about it. Energy level of orbitals, and then we are going to talk about the energy levels of the orbital, and then we can talk about the electronic configuration. Now, quantum numbers. Let's talk about the quantum number, the set of 4 numbers required to define the electron. So basically these quantum numbers are nothing but they are the address of any electron inside any of the atom, right? So these set of 4 required to define the electron completely in an atom are called quantum numbers. Principal quantum number, it tells about that at what energy level is it. First, second, third, fourth, what is the n value? And here is nothing but the quantum number, principal quantum number. So here these can have any integral value. Let's say if it is first, so how many of the subshells can remain here? I hope you all know that. For first one it will be only 1. In second one, how many of the subshells can be there? 2. In third, 3, 4, 4. I hope you understand it. In first one it is S, second one SP, third one SPD, fourth one SPD, fifth one SP3, SPD, FG, everyone, right? Azimuthal quantum number. Azimuthal quantum number deals with the, you can say, shape of the, where is that? Shape of the subshell, right? So it describes the the shape of the electron cloud that and the number of the subshell in a shell. So it can have values from 0 to n-1. One more thing, what are the things that you can find out with this? I hope you all know that MVR J equals to MVR equals to NH by 2 pi. Here n is what? Nothing but principal quantum number. Next is it can have values from 0 to n-1. If let's say that n equals to 1, so it will have 0 to 0, means L value can only be 0. So if it is 2, so 0 to 1 means 0 and 1. If let's say 3, so 0 to 2. I hope you understand. So values of L and subshell. Let's say if it is 0, then it will be S, 1 to P, 2 to D, 3 to F. I hope you know it. Number of orbitals in the subshell will be 2L plus 1. Okay, so number of orbitals in a subshell. What is the orbitals? Orbital in those subshells, those places where the electrons can be, so they are called orbitals. Maximum number of electrons, because in one orbital, how many of the maximum electrons can be there? 2. Pauli's exclusion principle. Now, and those two will have opposite spins, right? So particle subshell will be 2 into 2L plus 1. Next, orbital angular momentum. We can find out. How we can find out orbital angular momentum? OAM. What is the formula? Root of L into L plus 1 into H by 2 pi. I hope you all have to keep in mind these things. Next one, magnetic quantum number, M. M क्या बताता है भाई? What it says? It describes the orientation of the subshell. It can have values from minus L to plus L, not minus 1, minus L to plus L, including 0. So total value is 2L plus 1 values. Each value corresponds to an orbital. Every value is corresponding to an orbital. I hope you know that. For S subshell, so 2 into 0 plus 1. How much of the value will be there? 1. And what is the value of this? 0. For P, it will be 2 into 1 plus 1. How much it is? 3. So give these minus 1 or plus 1, anything. 0, plus 1, minus 1, anything. Next, for D, I hope you understand it. 5. For F, 7. Spin quantum number. What is spin quantum number? It describes the spin of the electron. It has the value plus half and minus half. Plus signifies the clockwise spinning, and minus signifies anti-clockwise spinning. Spin magnetic momentum is how much? Root of n into n plus 2. Here n is the number of unpaired electrons. Maximum spin is equals to half of number of unpaired electrons. जितने भी unpaired electron है, just multiply it with half, you will get the maximum spin. Now, shape of orbitals, I do not think that you need to know about it. You already know about it. Px towards x, py towards y, pz towards z, s spherical, double shape, I hope for z. If it is xy, yz, zx, between xy, yz and zx orbital. But if it is axial d orbitals, what are the axial d orbitals? There are two. One is dz square and another is dx square minus y square. Dz square is towards z axis, while dx square minus y square is towards the x and y axis. Nodes. What is node? Node is the place where there is minimum or zero probability of finding electron. There are two types. One is radial node, another is angular node. Radial nodes towards the radius, angular node towards in any angular plane. What is the formula? The number of radial nodes. Number of radial nodes is n minus l minus 1. Where and here angular node will be, it is also known as planar node. Planar node. It will be how much? It will be just equal. It will be just equal to L. And total nodes will be equal to n minus L minus 1 plus L. L cancel. It is n minus 1. These things keep in mind. Next one, electronic configuration. There are three principles that you have to keep in mind. Aufbau principle says that if you are going to fill the electrons, you should always fill the electron in the lower energy first and then to the higher energy. But how will you understand which is higher and which is lower? On the basis of n plus L rule, that is also known as Aufbau's principle. What is n plus L rule? If the higher value is there, so higher energy. If lower value, lower energy. But what if two orbitals have clash of n and L? Then you will see that which of the having higher n value. If higher n, higher energy. Lower n, lower energy. Means higher principal quantum number, higher energy. So how we can say that? Let's say there is 4p and 3d is there. 4p and 3d. So 3 plus 2, 5. 4p. 4 plus 1, 5. Clash between n plus L. But the point is that 4p will be of higher while 3d of lower energy. The reason is here in 4p the n value is 4 while in 3d the n value is 3. I hope it is very clear, right? Next, energy level of the orbital. Always remember, if it is one electron system, so it only depends on n. It does not depend on L. So for 1s less than, for one electron system, 1s is less than 2s and 2p, both of them will be same. It will not depend on L. Independent of L. It only depends on n. That is principal quantum number. 3s will be equal to 3p. That will be equal to 3d. I hope you understand it. So in the fifth cell, all the orbitals will be same. Next, energy level for multi-electronic system. This will be the same. I hope you all remember it, right? So 1s, 2s, 2p, 3s, 3. Okay. Next, Hund's rule. What is the Hund's rule? It is the maximum multiplicity rule. So if you have any, let's say 3p, let's say p orbital is there. If you have to fill the electron, so first of all the electrons should be filled. You can say all the electrons should be unpaired. So there should be maximum, unpaired electrons should be there, and then the pairing should be start later once all the orbitals are filled by 1 electrons. It is the Hund's rule. So no electron pairing takes place in the orbital in the subcell until each is occupied by one electron with the parallel spin. Okay, exactly half filled and fully filled orbitals makes the atom more stable. Half filled and fully filled is more stable. The reasons are, there are many reasons are there. So, but here you just have to keep in mind that they are more stable, and I hope you all know about it. Next, and if someone asks you the reason, exchange energy is there and symmetry is there. Next, Pauli's exclusion principle. What is the Pauli's exclusion principle? Pauli's exclusion principle, I hope you all know that every orbital can have only 2 electrons, and both of the electrons will have different spins. If one is having plus half, another will be minus half. Which one is plus half, minus half? Not to say. No 2 electrons in an atom can have the same set of all the 4 quantum numbers. An orbital can have more than 2 electrons. So, of course, anyhow, at last, either n or l or m or s, something will be different for any 2 electron in any atom. Which of the following set of quantum number represent an impossible arrangement? N equals to 3, L equals to, M equals to minus 2, and S equals to plus half. I hope you all can see if N equals to 3, L can have the value from N0 to N minus 1. So means N minus 1 means 3 minus 1. So L key value to 2 is okay, na? Of course it is correct. So if N equals to 3, L key value to correct here. m की value -2 for sure. M can have -L2 plus L, so -2 to +2, or you can say plus -2 minus plus, no issues. Okay, so of course it is also correct. S की value always either plus half or minus half, so of course A is the correct one. So what it is asking for? Acha, impossible. Sorry, it's not possible. It's impossible. N equals to 4, L equals to 0, M equals to 0, S equals to plus half. Of course, it is also possible. N equals to 3, L equals to 2. Less than N, for sure it is correct. M equals to -3. No, M can only be from minus L to plus L. So -3 is not possible because L is the 2. So of course the C is the correct option. Next one. For a d electron, the orbital angular momentum, what is that? OAM equals to root of L into L plus 1 into h by 2 pi. What is the L value for d electron? L value is 2. Root of 2 into 2 plus 1, that is root 6 into h by 2 pi. So just see that. A. Next one. A compound of vanadium has magnetic moment mu equals to 1.73. Always remember, if N is unpaired electron, if it is equal to 1, 2, 3, 4, 5, 6. I hope you understand it. So what will be the magnetic moment in Bohr's magneton? In Bohr magneton, it will be 1.732. It will be somewhere 2.82, 2.9. It will be 3.9. It will be almost 4.91. It will be 5.93. It will be 6.9 something, whatever. You have to understand it when the unpaired, whatever is the unpaired electron here, you can say the whole number is 1. When the number of unpaired electron is 2, whole number is 2. So if it is giving 1.73 Bohr magneton, means unpaired electron is how much? Unpaired electron is 1. If unpaired electron is 1, so it is talking about vanadium. Vanadium ka, can you tell me what is the atomic number? Of course, 23. So it will be 4s2 or 3d3. 4s2. So to make only one electron, how many electron you have to remove? 2 from S and 2 from D. So of course, to make it, how many of the electrons are there? 5. 2 plus 3. So to remove 4 electron, V plus 4 will be how much? 3d1 4s0. Because the first electron is removed from the valence shell, that is fourth shell. 4s0, 3d1. So plus 4. So how much of the plus charge should be there? Plus 4 charge should be there. So x equals to how much? 4. Very easy. The orbital angular momentum of an electron in 2s orbital. Root of L into L plus 1, but L is equals to 0. So therefore, overall value will also be 0. Match the following species with their corresponding ground state electronic configuration. Copper plus 2, zinc and Cr plus 3. Of course, you can see that because we have to understand that chromium and copper, both of them they are exceptional. They are exceptions here. So here what happens? 4s1 3d10. Why? Because it is half filled. So you can see copper ke liye 4s1 3d10, 4s1 3d10, 4s1 3d10. Of course, this one should be coming with first C. Cu plus 2. 2 electron remove. Remove the 2 electron. 4s0 3d9, 4s0 3d9, 3d9 3d9. For sure, it is going to be D. Zinc plus 2. 4 is, because it is 30. 4s2 3d10. So first of all, electron will be removed from S. 4s0 3d10, 3d10 4s0. Of course, it will be A. Chromium plus 3. Chromium plus 3 means 24. 4s1 3d5. First 4s1 and 3d5 में से 2 electron remove. 3d3. Where is 3d3? 3d3 E. Fourth E. You can just see that whichever is the correct option, you can just do it. And that is all. Thank you. So one thing I will tell you, bachcha log, please go through all these concepts. I have made you solve all those important types of questions. That is very much expected to be there in the examination. Please keep on doing more and more number of questions and keep on revising and just be with us. The next day we are going to